started. So yesterday we saw non-local scope, then models and packages, how to create modules, how to create packages, how to import them and how to use them in another program. Then doxing and annotations to describe our functions or to get help with them. So today we'll be starting with multi-threading and multi-processing. So before starting this, we'll first see what multi-threading is and what multi-processing is. Okay. So what's the difference between thread and a process? So thread is a part of process. Process is a complete program, is a whole program. And now threads are just the execution of that program. So thread actually, so what happens when a process executes is CPU allocates some amount of memory and some amount of resources for any specific process. Then the threads of that process use that memory or resources allocated for that process. So as you can see, process is parent and thread is nothing but the child of that process, which is using resources of their parent, right? So as process is a parent, process can have multiple threads, right? And so those multiple threads will share the same amount of resources of process. Okay. So if you are saying that a process is allocated, let's say suppose 10 units, and there are 2 threads, then those 2 threads will be using the same 10 units. Let's say one thread is using 3 of them and another is using 7 or another 4 of them. Okay. So that's how that's we can differentiate process and threads.
Resources.
Yeah.
What do you mean by resources?
Okay, so the resources means the memory allocated to a process, like the heap memory or the memory allocated in RAM. Then let's say there is a process which requires IO operation, input output. So there is a specific port in computer, so that is allocated to a specific process, right? So that resources can be used by threads. And when we say multi-processing, it means 2 different processes, and each process will have its own resources allocated to itself. So as you can say, processing is a bit overhead. Multi-processing have a bit overhead because it contains a separate resources, separate memory management, separate CPU executions for each different process, right? So in same program, if you are implementing multi-threads, so that's like a less overheaded operation because threads are nothing but just using its parent's memory. But if you are creating multi-processes in same program, then it will create a bit much overhead, not too much, but there will be overhead rather than or the greater than one which was there in 3D, because we need to allocate all different things for different processes. Okay. So when to use threading and when to use processing, right? So basically there are 2 things: concurrency and parallelism. Okay. So like instead of explaining their definition, I will just tell you where threading is used and where processing is used. That's more sophisticated to explain. So we can use threading when there is a time-bound operations, okay, like IO operations. Suppose user is giving input. Now let's say user haven't given an input for 5 seconds. Now what is CPU doing in those 5 seconds? It's just stable. It's doing nothing, right? So that's the waste of our resources. So thread is just there waiting for the user to input any value and then running next code. So what if we don't want to wait for user to enter input, but we have another operations which we want to perform in that time. Or let's say we have sent a specific request to any URL, and until the response comes, we want to execute some other task. Right? There is no point in waiting for someone else to reply us, and then we'll continue our work. So that's why we use threading at those times when we don't have to wait for another thing to complete. That's when we use threading. If we need to use multi-processing, let's say there is a CPU intensive task. Now, what happened in threading? It was time intensive, right? There was a time in which CPU was idle, but in multi-processing, CPU isn't idle. Let's say you have to calculate squares from number 1 to 100. Okay. Now, if you do this in let's say one go, so there will be 100 iterations. For each number, we'll be iterating for 1, then calculate square, for 2, then calculate square. Using multi-processing, what we can do is break 1 to 50 and 51 to 100, right? And then run same program on these two data. So those both will be running in parallel. There is no waste of time in CPU because for both cases, CPU isn't idle for a second, not for a millisecond, right? CPU is being run at every moment of time. So that's when we use multi-processing. I will implement it then you will get to know why we're using threading and multi-processing. So to use threading, we need to import a thread method from threading library. So from threading, import thread. Okay. Now let's say I have a function def, let's say print or intro. Okay. Now what this function does is print hello. There is a method called sleep which puts our processor to sleep. But, which model it is, I don't remember. Just a second. So in case you don't remember any method or don't know where to find it, just open Python's documentation and just search for it. It's better. Sleep. Let's say yes. Time dot sleep suspends the execution of calling thread for a given number of seconds. Okay. So let's import time. Then time dot sleep, let's say 10 seconds. Okay, print 10 seconds complete.
Wait.
It just execute this function normally like we used to do. What this is doing is it will print hello, then time dot sleep will put our processor to sleep or the thread to sleep, not a processor. And for that time, CPU will be idle, not executing anything. It will just be there doing nothing. And then after 10 seconds, it will print this 10-second completed. Let's run this file. Okay, hello. It will wait for 10 seconds. Yes, 10 seconds and 10 seconds are completed. So 10 is a bit much. Just make it to 5.
It's in second.
Yes, it's in second. 5 seconds. Okay. Now, what if I want to call this function twice? Okay. Same function twice. Let's say intro. Let's calculate the time which these two functions took to execute. So how we can calculate the time? We'll record the starting time, and then we'll record when the all function code is executed, and then we'll record ending time, and then we'll just ending from starting. That should give us the execution time, right? So starting time is time dot time, and then when this all functions finished execution is time dot time. Print time taken is end minus start. All right, as you can see, the time taken is 10 seconds, right? And then there are some milliseconds and all. So that's after decimal point. So why 10 seconds, right? So at first time we recorded the start time, then it called the intro function. Then intro function printed hello. Then the thread went to sleep for 5 seconds, right? So CPU was doing nothing for 5 seconds, and then it printed 5 seconds completed. So 5 seconds went here, and then another we called intro function. So another 5 seconds went here. So in total, the execution took 10 seconds. Right. Now, what if I want to execute these functions? Okay, but I don't want this function, I don't want to wait this 5 seconds to execute this next call for this function, right? So even it's sleeping for 5 seconds, I want to in that 5 seconds I want to execute this function again, right? So at this time we can use multi-threading, right? Why? Because we are just there is a time bound, right? So why time bound? Because we are waiting for that specific time. For that specific time, CPU is doing nothing. At that time, we can use multi-thread, so that CPU won't be idle for a long time. When we call sleep, the CPU is idle for that time, whichever we can specify. So what we can do is we can implement multi-threading. To implement thread, let's say we need to create 2 threads, okay, for calling this function 2 times. So the one thread will call this function one time, then the second thread will call this function second time, okay, so that this function will be running on 2 threads. So let's say thread 1 equal to thread bracket, then there is a target, and in as a target parameter we specify the function we want to pass to that thread. So we want to call intro, we will just pass intro. Then I will create another thread, thread 2, will pass same function. Okay. Now we are just assigning this target to our threads. We haven't started execution of these threads yet. So to start the execution of thread, we have inbuilt method called start for the thread object. As you can see, we are calling this thread method and then specifying the target which we want to execute, and this is returning something in thread 1. So what is it returning is a thread object. Okay. So this object have a method called start. So I will start thread 1, thread 1 dot start. Okay. Similarly, I will call thread 2 dot start. Okay. Now what happens is thread 1 will start executing this intro function, and in the next iteration thread 2 will start executing this same function. Okay, so what happens when this thread will complete its execution of those functions? So to terminate those threads, we have join method. Join will just close those threads and we'll just merge them into our base process or parent process. So thread 1 dot join, thread 2 dot join. Okay. Now we'll calculate the time threading took. Start equal to time dot time and print multi. Start sequence. Okay, let's run it. Alright, so at first our this base execution will run, like calling this intro for 5 seconds, then sleeping the CPU for 5 seconds, again calling intro function, again sleeping for 5 seconds, and then we are calling these threads. Okay, here in output, this execution is for our base code, which is here, without anything, just regular code. So these first 2 lines took 5 seconds, hello and 5 seconds completed, right? Because CPU was sleeping 5 seconds in between this execution. Again calling that function took the same time, 5 seconds, and overall it took 10 seconds. And then from here we started threads, and it took only 5 seconds instead of 10. So the time reduced by 50% completely. Now what happened is thread 1 started executing it. As we said, thread 1 dot start. So thread 1 will look at its target. So its target was intro. Now it went to intro here, and it's saying print hello. As you can see, it's printing hello. Right now, time dot sleep 5. Now this thread went to sleep for 5 seconds. Okay, so this thread have no work to do. So what CPU does is, or what Python does, not CPU but Python. Threads are managed by Python. Okay. So what Python does is, until this thread have no operation to perform, it will look for another thread. So there is thread 2. What thread 2 does is, again went to intro function. Again thread 2 printed hello. So as you can see, there is again hello, which is by thread 2. Now again thread 2 also went to sleep. But now, as we all know, thread 1 went to sleep before thread 1, before thread 2, right? So when thread 1 completes this execution of this process, time dot sleep 5 seconds are completed. Then thread 1 will say that I want to execute another statement, which is print 5 seconds completed. So this is executed by thread 1. And then thread 2 again completed is 5-second interval, and again thread 2 will also print 5 seconds are completed. So there is no like we can say restriction of time. So the two threads are running along with each other. When one thread stopped its execution, thread 2 begin its execution. So that's why overall it took only 5 seconds to complete the execution of same function. That's how we can use multi-threading. Simply just to repeat all things again, what we did is declared a thread object, pass the function we want to do multi-threading with. It will be returning object of thread 1. Again, to start that thread, we'll be just calling start method of that thread object, and to end that execution, we'll just calling join method. That's all. That's how threading works. So I'll just write here steps we perform. Define thread object with targeted function, then start the thread, join the thread. That's it. Okay. So that's all about threading. Now we look at multiprocessing. Oh, so in target you are actually passing parentheses, so it's executing function and
Okay. So target is not a function.
no, target is just a variable. So what it's doing is it's executing intro, and intro is returning null. So target is null ultimately. So those threads are doing nothing. So multiprocessing, as we already said, multiprocessing is used for a CPU intensive task. Now we'll see what are CPU intensive tasks. Okay, so multiprocessing. Let's say there is a function called intro is done. Say hello. Let's say any CPU intensive function. Calculating squares. Okay. Now evaluate by for loop, like just a regular method for I in range 1 to 100. Insert equal to result of print times. Okay. Right. So before we defined intro function, which was time bound, and now we have hello function. Okay. So what difference this hello and intro was like putting our thread to sleep for some seconds, so the time was wasting there. But here, as you can see, the time isn't being wasted for a minute time here. So CPU will be continuously running for this whole loop, right? So CPU won't be idle for any moment. At any moment, CPU will be doing its task. Now to improve this tasking method, we use multiprocessing, right? So let's say you have big data, for example, let's say 10,000 operations you want to perform. Now if you run it using only one function and calling it once, so it will go over those 1,000 loops, 10,000 loops. we can break it in 2 or 3 or 4 multi-process. Like one can operate on 1 to 5,000 data, and another can operate on up to 10,000 from those 5,000 first method. All right. So let's just, for basic understanding, let's call this hello function. Print calculated squares. Print start date. Start equal to time dot time equal to time dot time taken. I will just comment out this threading methods. Now let's run our hello function. Okay. So to calculate squares from 1 to 100, CPU took 6.5 seconds into 10 raised to power minus 5. Right. So that's a very minute seconds too. So let's say I increase this one. See how much time it took. Okay, we can work with this 2 seconds. I don't know for how many numbers it's calculating squares. What is it? It's 10 million, I guess. So for calculating squares of 10 million numbers, CPU took 2.4 seconds. All right. So before going to our multiprocessing, you first need to know how many cores your processor have. Okay, so process runs on each core of our processor. It's related with hardware. So you need to know on which specifications your system are running. So let's implement multi.
Those squares, the time will increase.
Yes. Yes. The difference won't be much, but it will be there. Like if you printed in each column, then it will be more. But if you printed at a time, then it will be lesser than that. Yes.
Prathamesh.
Yes, Manda.
Yes, Tejas here.
Yeah.
Actually, what is the meaning of time dot time?
Yeah, time dot time is returning the current time.
For current time, okay.
Let me just print it for exploration. Okay, as you can see, it's the current time in integer format.
Okay, got it.
So it took almost 2.4 seconds, right? Now let's implement multiprocessing. So basically, even with multiprocessing, it's going to take the same amount of time. Okay, because we are not dividing work; we are just exploring how multiprocessing works. Now, what if I call this hello function twice? Obviously, the time which this function will take to execute will be 4 seconds. Right, 4.17. Write it here. 17. Now let's call this both functions using multiprocessing. So for using processing, we can import from multiprocessing. Import process. Right, from threading import thread from multiprocessing import process.
Prathamesh,
Yes,
Can we,
Manzan.
is it possible for auto import, like any keys will be there for shortcut keys? If you write any, suppose import method or something, or we need to
Uh,
write manually, like import
Actually,
multiprocessing like this.
you need to input what you want to do manually, because
Okay.
even if you just wrote process here, the ID will suggest you to import this module automatically from multiprocessing. So that can be automated, which will be held by ID. But you can also
Okay.
define, like if you know what you're going to need in your program, then you can just
Mhm.
define a function and importing all those. But that won't be like making much difference, right? Even like even though you still have to write what you want to import. So
Yes, same thing will be suggested. Yes.
yeah,
No, no. It Python will suggest, auto suggest what method
yeah.
will
So
do it.
that
Yes.
that auto suggestions will be given by ID. If
Okay.
you don't import anything and will just use it, then Python will throw error.
Mhm.
So you have to rely on ID to import that for that process.
Okay.
Like say you are writing your code in editor rather than ID. So editor don't suggest you to import something, like not many
Okay.
editors.
Mhm.
It would, may suggest, but Atom or Sublime Text won't suggest you to import these things.
Okay. Yeah.
Now working of process is also same as threads. Let's calculate start equal to time dot time. Then let's create a process one. Process one equal to process, same target will be hello, process 2 equal to target will be hello. Then process 1 dot start, process 2 dot start, 1 dot join, process 2 dot join. Then end equal to time dot time. Then we'll print the time taken by multiprocessing. Right, let's run it. So at first we'll be executing this base execution, which will took 4 point now. Already it's taking more time now. Alright, we imported processes now, so the importing took more time. Okay, so the multiprocessing took 3.53 seconds. So it's better than this regular execution, obviously, but I was hoping that it should take the same amount of time. Alright, it's taking 4.28. So what may have happened to reduce this time was in our base execution. So this hello hello method was being run on same thread as the base thread of our Python program. But in multiprocessing, this whole method was considered as a different process rather than this our base process. Right? So maybe that may have improved our time execution 3.53 than 4.28. But what we are doing is calling the same method, right? We are not optimizing anything. Both methods are doing same thing, calculating squares from 1 to 10 million. Now what we can do is divide this 10 million in 5 million, 5 million cases, and then run these two process differently, so that we can almost save this time by 50%. Actually, you are getting what I'm trying to say. Or yeah. All right. So what multiprocessing did is, let me just write it here. What multiprocessing did is call this. Which method was it? Yeah, call this hello method. Right. Now we have two processes, right? Two processes. Each process, call them separately. Now you can imagine this as two processes are running parallelly. Okay. So let's say process 1 is on core 1 of our CPU, and then process 2 was on our core 2 of our CPU. Process 2 on core 2 CPU. These two are running parallelly. What we can, let's say, draw it here. Process 1, process 2. These are running simultaneously. All right. Oh, so actually it took more time than it's supposed. It should have taken half of this, right? Because at first we have been calculating same method again and again, but now we are just divided it, and these two should be executing parallelly. So as threads did, threads was able to reduce time by almost 50%. So if a thing is taking 5 seconds, then thread executed it in 2.5 seconds. So multiprocessing didn't did that. So if we should be expecting 2.1, but it took 3.53 seconds. Now why this happened? So the basic explanation for this is it took more time than expected, because as we already discussed, process needs to allocate some extra resources for it, overhead, which we can call overhead. So that overhead took more time than it's supposed to. So if we can see task manager here for Ubuntu, I don't know how to access task manager for Ubuntu, but if you could see, then you can see there is a bump in CPU usage when we are calculating these both processes at the same time. Okay, so that's why if you are running multiprocessing, you cannot expect it to like completely dropped by 50%, but it surely improved our time of execution, right? So let's do the same thing by like optimizing this thing. Okay, so we are processing the same method on two process or at the same time, or on two cores of our CPU at the same time. Now what if I said this process 1 should execute only half of my code, and the another half should be executed by this process? Now this should improve our timing, right? So let's say I will modify this function. Start begin, say begin, then we'll go from begin to end. Just a second. Not this hello function to run from 1 to now to pass arguments. Here we are just specifying target hello. Now how to pass arguments to this hello is using comma, and there is another parameter which is args for us, like stands for arguments. Then we can pass our arguments. Let's implement same thing again. Start equal to time, then create process 1 equal to process target hello. Now let's divide it. It was 10 million, let's make it 5 million. Then same way process 2, these two, let's execute this both methods. Start process 2 dot start process 1 dot join. I'll explain this all again, so for better understanding what's happening. Let me just implement it. Process 2 join equal to time dot time print tactical in the minus. run it. Started or base calling of method is to 4.2 seconds. All right. So when we called sequentially, let's go through code again. There is a hello function which is taking begin and end as a parameter, and it will be calculating square for those begin and end, right? Between those for numbers between those begin and end. Now we just called our hello function like in typical way in same thread of Python, and then calculated time. So the time it took was 4.2 seconds. Then we implemented multi-processing and called the same method on same parameters. Okay, so the time it took was 3.09 seconds, which didn't decreased by half because there was overhead of allocating resources. That's why it took more time than required. And then then what we did was differentiated our task into processes. Instead of calculating the squares from 1 to 10 million, let's say first process is calculating squares from 1 to 5 million and another is calculating from 5 million to 10 million, and both processes are running parallelly. So this decreased our time of execution so much drastically. First it was taking 4 seconds, now it's taking only 1 second to execute 10 million squares in 1 second instead of 4 seconds. You can see it's huge improvement.
Just divided.
Yeah, right. Instead of workers, let's say if one worker is doing 10 tasks, let's say we bring in 2 workers and one will do 5 and another will do 5, and both are doing parallelly. So that's how time is being managed.
But it is 1 to 5 and 5 to 10. Yes.
Yeah, 6 to 10.
Yeah. Then 1 to 5 to like come and like 5 to 10 to.
Well,
coding depend on.
Actually what we are doing is we are passing the hello method, right? So the logic is same for both.
Future. Yes.
But
That's on the method.
yeah, let's say even if you are yeah, actually it's depend on methods. So both both workers are getting same methods, right? You are saying you have to perform this logic and another worker is also gives same logic, you have to perform this logic. Now as you are seeing worker one may complete the work earlier than worker two, right? So this can happen. Let's say we are calculating if condition, there is an if condition, so if this condition matches then and only don't perform the big work and else don't perform it. So no problem, it will just take the amount it took for process 1 and process 2, both are simultaneously, so whichever ends last, that time will be calculated from start to end, right? Is there like marker, I will explain it on whiteboard like how multi-processing works. Okay, so basically code wise it's completed here. Okay, so Mandar, did you get it how it's executing?
Yes, only process one dot that below code, no? It start to end process. Can you just explain process one dot start and two dot start?
The ending one, like we divided
End,
work by 5
yes,
million.
end equal to time dot time.
All right, so why this how this time thing working? So
Correct.
all right, so what we are doing is time dot time is returning current time. Okay, let's say there is a time is 12:17 p.m. So it's returning it in integer format. Okay, it's not like 12:17 p.m. or anything. It's not timestamp, it's a time in integer format. Or instead of integer there may be another format of time. You can check it using type of time dot type. It will show you what what data type it's returning. But let's, for understanding, assume it's returning the current time. Let's say time dot time return 12:17 p.m. for start. And then we executed all of our code between after this time dot time line. And at the end of our execution, let's say my work is ended here. Now I want to see what time it's now. So I will be again calling time dot time. Now time dot time will return current time. Now current time is 12:18, right? So when I started work, the time was 12:17. Sorry.
Yes. Yes, go ahead.
Yeah. Right. Go ahead.
Yeah, so start will be 12:17, and if user has end time, it will be 12:18. Right, so
Yeah.
so we have to join process one dot join and process two dot join, correct? So start and end time.
Yeah.
It will show. It will print.
No, actually, this join thing doesn't don't have anything to do with this time dot time. Okay,
Okay.
so time dot time is running in our base process. This all code is executing in base process except this process one dot start and process two dot start, and then this join method. This thing is executed in different environment, in different processes. But
Mhm.
this code won't get here until this join method is performed. And join method will only be performed when these two things will complete its work. So when process one will complete its execution of this method hello, then and only then this process one dot join will execute. And when process two will complete its work of executing this hello, then and only then this process two dot join will execute. And after that, this end equal to time dot time will execute. All right. So
Okay.
unity.
Mhm.
So this will execute only after this all processes are being executed and completed execution. And then we are just calculating the time to by in dot sorry in minus start. So like 1218 minus 1217 will give us how much time it took to execution.
Okay. Yeah.
That's all for
Thanks.
uh, threading and multiprocessing works. Like so, there is nothing more in our schedule. For assignment, you can implement this multi-threading and multiprocessing. Multi-threading you can implement on request library. Request library is for calling a URL, then getting response from it. You can explore it on Python, on like not Python. It's not Python's base library. It's an add-on library. Okay, so I will give you an API which will be returning a random number, and so you can perform it on those API. It's a I will document this assignment and will share it with you instead of saying verbally. So that's it for the day. Any doubt, Mandar and Tejas?
No, Prathamesh.
No, Prathamesh.
Okay, so can we can go through all over this again in 5 minutes, what we learned and all. So what we did in 7 days was installation, then created Hello World, created virtual environment using PyCharm. Okay. We haven't seen how to create virtual environment using terminal. You can look up how to create a virtual environment. It's like a module of Python 3, which is virtual env. Okay. So then usage terminal ID. So we have only seen on ID, not on terminal or on online interpreter. It's a simple on terminal. You can just say Python 3, and you will get the execution environment for Python 3. You can execute any Python commands here. Print hello. That's it. That's how you can run Python on terminal. And on online interpreter is just searching for Python online compiler or interpreter. It will show you results. Then go to any result and type code and run. It will just run online. Then data type, variable type casting. The typing and dynamic typing are same. Okay. So we have seen this. Then operators, we have seen it. Identify type of variable using type. Right. So this was nothing but just a type method. That's it. Then we saw data types like list, tuple, dictionary, set operations, then the length. Sorry, so did we saw length? Like we were using type method, type, and then in bracket we are providing data type. Using same thing, you can use len function, len. So let me just show it to you. Python 3. Let's say there is a list 1, 2. As we can see with our eyes, the length of this list is only two elements. You can check the length using this length method, len method, and then pass this data type or variable, and you can see the length of this a is 2. Right? Even if you pass string to this length, it will just return the length of that string. Say hello. So the length of hello is 5. Right. So after that, slicing. So slicing, okay, so slicing is also remaining like this. 3 and 4. Now we have a list A which has elements 1 to 4. As we know how we can access elements is using square bracket and let's say 1, it will print 2. Okay. What if I want elements from one index position 0 to 2? So 0th position is 1, 1st position is 2, and 2nd position is 3. So it's simply from 0 to 2. That's called as slicing. From list A, select element starting from index 0 going to 2. Enter. So 0. So as you can see, it's printing elements from at index position 0 and index position 1. So 2 is excluded. So it's exclusive operation. So you can see, you can also pass here len of it. It will print all the elements of it, right? 0 to completely length. That's how slicing works. Nothing much. Then conditional loops, we have seen it. Then comprehensions, list comprehensions, map, filter, reduce, functions using def keyword, right? Define function using def, then give function name, then parenthesis and define parameters. You can also assign default values. You can search for star ARJS and star KW ARJS. So this is a type of parameter. I will just document it and will send it to you what you have to look up. Then there is a exception handling, try except finally else, how to read errors, file management, different modes of opening files, read, write, append, then open, close, read, context manager using with keyword, was context manager. Then object oriented concept, we saw class, objects, initializer, which was init method, then class attributes, which is just a variable defined in class, then methods, which are just function defined in our class. Method versus function. Methods are the functions defined in class, and functions are the methods. Sorry, functions which are not defined in class are just functions. Then abstraction using ABS class. Then encapsulation, which means getter or setter methods. Then inheritance, inheriting parent class to child. Then polymorphism, function with same name but with different logic is polymorphism. Then we saw scope, global, local, non-local. Global is completely outer scope, local is completely inner scope, and in between global and local there is a non-local. Then decorators, which we can call using @ before functions. Modules and packages. Modules and packages are just directories and Python files. Then docs and annotations, which are used to explain our functions, what our function is doing, what parameters it's accepting, and what it's returning. Then OS module, path module, which we use to see the current working path, change directory, creating directory, and deleting directory. Then we saw pip yesterday, how we can install other packages using pip. Then multi-threading versus multi-processing, we saw it today. Okay. So it's all done. Right. So right, Mandar left. Okay. So Tejas, is there any doubt till the time?
No, Prathamesh.
Okay, so the recordings were shared with you by Rachel, right? So there is a drive folder, you can refer to those. Also the code snippets are also being shared on drive. You can also refer to those documents to get started
Sure.
with your assignments.
Yeah,
We
sure.
can end up today's session. Thank you all.
Yeah. Thank you, Prathamesh.
You can always get back with me if there is any problem with any assignments or
Yeah, sure.
any future. Thank you.
Thank you.